Solving right triangles. Okay, a lot of this isn't new. A lot of what solving right triangles is things we've done up to this point in this semester. Um, However, we now have new machinery that allows us to do a little bit more for solving right triangles. So we're going to go cover the whole thing at once. Some naming conventions in right triangles. Um, we have A, B, and C. They represent angles. C is always the right angle. A and B are always the acute angles. And we use lowercase letters A, B, and C. So uppercase A, B, and C for angles, lowercase A, B, and C for side lengths. C is always the hypotenuse. A and B are always the legs of the right triangle. Notice that an angle and its opposite side share the same letter. Capital A, baby A. I say baby instead of lowercase because it's less words, and it makes me happy to say baby B. Baby B. Uh, so capital C, baby C. Capital B, baby B. Capital A, baby A. So solving a right triangle, all that means is we find all three sides and all three angles. Here's an example. We have this triangle, solve it, round all answers to the nearest 10th. We're missing angle A. We're missing angle A. We're missing angle B. And we are missing side length baby B. Okie dokie. So we have a bunch of different directions we can go here. I'm going to start with the angles. I'm going to start with angle A, but you could start anywhere on any one of the three. So my first step, though, solve for angle A. All right, so for angle A, we are given two side lengths here. I'm going to do a brief little sketch down here. Boom, boom, 61, 60. And angle A is here. So for angle A, the opposite side is 60. The hypotenuse is 61. So we have opposite and hypotenuse. That's going to be so opposite and hypotenuse. So angle A is equal to sine inverse of the opposite side, 60, over the hypotenuse, 1. 61, not 1. A is equal to sine inverse of 60 over 61. And if you plug that into your calculator, you should get 79.6 degrees for A. That's solving for A. Next, solving for B. Here's the thing, you have options. You have options on how you do this. There's the easier method. This is the easy way. The easy way is saying, hey, there's 180 degrees in a triangle. We know one of the angles is a 90-degree angle, and then angle A was 79.6 degrees. So if you subtract, you should get that angle B is equal to 10.4 degrees. And indeed, it is equal to 10.4 degrees. It is equal to 10.4 degrees, and that is the easy way to do it. However, if you want to use trig instead, we would do the same type of thing we did with angle A, because you didn't have to solve for angle A first. You could have solved for angle B first. Angle B is right up here. For angle B, 60 is the adjacent side. So the adjacent side is 60. The hypotenuse is 61. And we have adjacent and hypotenuse. That's So ka toa. So angle B is equal to, that's cosine inverse of adjacent 60 over hypotenuse 61. And if you plug this into your calculator, you should still get 10.4 degrees. So either way, you end up with 10.4 degrees. All right, finally, we're solving for baby b, the side length b. And again, you have options here on how you approach this. You can solve for b using, ooh, that is too big of a pen, using a squared plus b squared equals c squared, so the Pythagorean theorem. So we have b is equal to the square root of c squared minus a squared. So b is equal to the square root of 61 squared minus 60 squared. And I chose a Pythagorean triple for this problem, so this comes out to a perfect 11. And that is the answer. But if you wanted to do it with trigonometry, you can set this up and do it with trig instead. So for this guy, so we're looking at b over here. And we need to join it with another side length. So we can do 61 or 60. I'm going to go ahead and use 61 because that will put b in the numerator for me. And I know the measure of both angle A and angle B. I just have to be a little careful here. When I go to set this up, let's see. So if I'm using angle A, we know that angle A, if I use 79.6 degrees in my calculator, there's a possibility that we end up with a rounding error because we rounded this number to begin with. So I would really need to use the really obnoxious definition of angle A, which was right above it, the thing we plugged in the calculator, the exact value. And so we have angle A, then we have a hypotenuse that is 61. We have adjacent, which is B. Adjacent and hypotenuse, that's cosine. So cosine of sine inverse of 60 over 61. So that's cosine, this is really cosine of angle A, but angle A is sine inverse of 60 over 61. Is equal to adjacent over hypotenuse, so b over 61. You multiply by 61 on both sides, you'll get 61 cosine of sine inverse of 60 over 61 because you multiplied this, 61, 61. These cancel, boom. And if you plug this into your calculator, you should get exactly 11. So it's the same answer either way. This is obviously more complicated of a method down here, but it does work. All right, so that's how solving triangles go. We've already done situations where we've been given an angle and then you have to solve the triangle. So this is the only thing that's new here is we're not being given any angles to begin with. But it's a straightforward process and you really only need to use trig once. Everything else can be solved the easy way. All right, so that's that for this video. I'll see you in the next one. Bye.